What's up everyone, welcome back. Patrick here, and moving on to the next video, what we have to do here is we got to take each of these products here, we have to model them using algebraic tiles, which we've done in videos before. But now what we're going to be doing is using the distributive property to verify our answers algebraically. So when you're going through this question, I'm assuming that you've already watched the videos where we've modeled these kinds of products using algebraic tiles. Hopefully you've watched those. There's going to be lots of carryover. If you haven't watched them, highly recommend you go to the site and watch them, follow it in order. If you're watching this on YouTube, there's a link to the site. It's in the description box. So starting with part A, we got 2x plus 1 times x plus 2. So let's start off with the algebraic tiles first. So the 2x plus 1, notice that there are two x's. So the way we do that, let's let this 2x plus 1 be the base of the diagram we're going to draw. So remember, an x we represent with a large line like this, and there's two of them. And then we have the plus 1, which we represent with a small line like that. So we have an x, and then a 1, right? 2x plus 1. And then we have x plus 2. So the x plus 2 will make the height. So we have 1x like this. So that's an x. That's going to be the same length as these lines here. And then we have a plus 2. Actually, you know what? Let's I'm going to make it a little shorter so we can add in that plus 2 there, right? There's like a 1 and a 1 over here. So we got 2x plus 1 and then x plus 2. And then what you want to do here is you just want to create a box. So first we start off with the outer portion. And then any spaces here, we want to create a horizontal line. So notice there's a space here. So we can create a horizontal line, a space here. And then there's no more spaces over here because this is a full line over here representing that x. And then the same thing on the base. Any spaces, we create a vertical line. So we'll have a vertical line, and then we'll have a vertical line like that. And then from here, you want to see what kind of shapes do you end up having. So notice that we have two squares over here, and each of these large squares here, they represent an x squared. And then we have these rectangles here, so the rectangles represent x's. So we got an x, and then also an x over here. The rectangles can be horizontal like this, they could also be vertical like this, but they still represent that same value of x. And then notice we got these two small squares here, and those represent 1s like that. So then what we do is we just add everything up. So notice that we'll have x squared plus x squared, so that would be 2x squared. And then we have 1, 2, 3, 4, 5 x's, so we'll have plus 5x. And then we have 1 plus 1, which would give us 2, like that. And so 2x squared plus 5x plus 2 ends up being the product for that. And we just showed it with algebraic tiles. Now what we got to do is we got to verify it using the distributive property, which is basically what this next section is going to be about, right? We're going to be multiplying polynomials. And so the way we could do that is we just FOIL everything out. So what we can do is we could take the 2x, multiply it by the x. So let's actually write it out in steps. So we'll have 2x times x. Then we could take the 2x, we can multiply it by the 2. So you'll have 2x times 2. Plus over here, this 1 will multiply by the x. So we'll have 1 times x. Plus we'll have the 1 times the 2. And by the way, you might follow a different order of multiplying over here. It doesn't really matter which way you add it. You should end up getting the same answer in the end. And so from here, what we could do, 2x times x, that would give us 2x squared. 2x times 2 would give us 4x. 1 times x would just give us 1x, or just x by itself. 1 times 2 would give us 2. And then you want to add up the like terms. We got a 4x plus x here, which would give us 5x. and then we have the plus 2, and then the rest are not like terms. So you can't simplify that any further. And notice that we end up getting the same product that we got with the tiles. And so we verified our answer, so we could be pretty confident that that is the correct product. So now moving on to part B, we got x plus 3 times x plus 1. So let's first start off with the tiles. So the x plus 3 I'm going to put as the base. So we got 1x, which is a long line like that, and then we have plus 3, so we'll have 3 of these small lines like that. So we got x plus 1 plus 1 plus 1, which is plus 3. Right, so that's the x plus 3, and then the x plus 1, let's put on this side as the height. So we'll have x, which is a long line, and then we got 1. So we have 1 small line like that. And now, as we've done before, let's attach the outer parts like this. And now notice there's a space here, horizontal line, no more other spaces to make a horizontal line for. And then here we got 3 spaces to make vertical lines for, like that. Right, so from here, notice we got a big square, which represents x squared. We have a rectangle, x, rectangle, rectangle, rectangle. And then over here, we have these small squares, which would be 1, 1, and 1, like that. Okay, so adding everything up, we'll have, notice there's only one x squared, so we'll have an x squared. How many x's are there? 1, 2, 3, 4, so we'll have 4x. And then we have 3 small squares, which would give us plus 3, like that. So with algebraic tiles, we end up getting x squared plus 4x plus 3. So now let's see what we get when we use the distributive property. So let's start off with x times x. Then we'll do x times 1 plus we'll do 3 times x, and then we'll do 3 times 1, like that. And what do we get? X squared plus x plus 3x plus 3. And then notice that these two are like terms that we can net out. X plus 3x is like 1x plus 3x, which would give us 4x. And then we have a plus 3. And notice that's the same product that we got before. Right, so this here, x squared plus 4x plus 3, ends up being the answer for part B. So let's write out the answer up here. And now let's move on to part C. So we got 2x plus 3 times 3x plus 1. So this one's going to be a larger diagram. I'm going to put the 3x plus 1 at the bottom as the base. It doesn't matter, you could put the 2x plus 3 as the base as well. The reason why is because I have more room for the base here, and there's going to be 3 of these x's. So we'll have x, 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 so that's 3x. And then we'll have a plus 1 like that. And then for the height, we'll have 2 x's. I'm going to need more room here. So you know what? I'm just going to erase this part B over here. So we'll have x. We'll have another x. And then we'll have 1, 2, 3, like that. Right? So we're kind of pushing it with this diagram. So let me write part C over here, 2x plus 3 times 3x plus 1. So let's connect all of this. I'll leave part D on the side there too. So we'll have 3x times x plus 2. All right, so now from here, let's connect everything. So we have a space over here. We got a space over here. Another space, another space, and then that's it for the horizontal lines, and then the vertical lines right here, right there, and then right there, like that. Okay, so from here, let's see what we have. Notice that we're going to have lots of squares like that. Got lots of x's as well. That's an x, and then that's an x. And then over here, we got the small squares, which represent ones, like that. All right, and so from here, we basically have to add everything up. Let me erase this. So how many x squares are there? 1, 2, 3, 4, 5, 6. So we'll have 6x squared. How many x's? 3 by 3, so there's 9 over here. And then we have 2 more over here, so it's 11 of them. So we'll have 11x. And then we have 3 ones, so we'll have a plus 3, like that. Right, so this one's a fairly larger diagram, but this ends up being the product that we get when we model it with algebraic tiles. So now let's see if we get the same thing algebraically. So let's rewrite this over here. We'll have 2x plus 3 times 3x plus 1. So now we'll have 2x times 3x, like that. Then we'll have 2x times 1. Then we'll have 3 times 3x. And then we'll have 3 times 1. By the way, you don't have to write out these products like this. If you're fairly comfortable just multiplying, just make sure that you're careful and you don't miss anything. And in other videos, when you're going to have different signs, it also becomes fairly critical to get the signs correct. So I do recommend when you're just first starting out, writing it out like this, and then as you get more comfortable, you can just go straight into multiplying. But we'll have 2x times 3x, which would give us 6x squared, 2x times 1, which is 2x, 3x times 3x, or sorry, 3 times 3x would give us 9x, and then 3 times 1 would give us 3. Like terms, we'll have 6x squared plus 11x plus 3, right? Which is the same that we got with the tiles. So we could be pretty confident that the product of these two expressions is 6x squared plus 11x plus 3. And then finally, part D, so we'll have 3x times x plus 2. So let's write it over here. 3x times x plus 2. Algebraically, this one's going to be fairly easy. With tiles, we still have this 3x over here, so let's put that as the base. So we'll have 1, 2, 3, and then there's no numbers there, so it's just 3x like that, and then we'll have x plus 2, so we'll have one line, which is x, 1, 1, 1, and 1, like that. And so, making the outer border first, we got a space there, we have a space here, and then space there, and a space there, like that. So notice in this case, we have 3 of these squares. So we'll have x squared, x squared, x squared, and then we got x, 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 like that. So notice there's no small squares in this case. So adding everything up, we would end up with 3x squared plus 6x, like that. And this is very easy to verify right here, because notice we would just use the distributive property like that. So we would have 3x times x plus 3x times 2, right? We're just basically taking this 3x and distributing it into the bracket. So we don't have to worry about multiplying with another term, because it's only one term over here. And so 3x times x would give us 3x squared. 3x times 2 would give us 6x, like that, which is the exact same product that we got here. All right, so just a little bit of review with algebraic tiles. Your teacher may or may not go over these, but it's a nice introduction to see how we can get that same product with algebraic tiles, or algebraically. And the algebraic portion, the algebraic process, is what we're going to be focusing on in this section.